This is video 7 on disease detection analysis with your Medmont E300 corneal topographer. Let's open up a patient file and select a corneal topography. With an axial map selected, we can see that this patient does not have regular corneal astigmatism. There isn't a defined flat meridian nor steep meridian. This is an asymmetrical eye and would be difficult to correct with simple spherocylinder overrefraction. We can select the tangential map and determine that the point of greatest curvature change is approximately 0.89 millimeters away from the visual axis. This patient's cone is fairly centralized relative to most inferior oval cones. However, we can see the size of the cone by these hotter contours and the position of the cone in relationship with the visual axis, and it's not a very centralized corneal apex. How do we determine that this is a diseased eye? We look at the simulated K readings and we see a fairly normal, although slightly steeper, flat K, 44.8. This would not be indicative of keratoconus. Certainly the 1.5 diopters corneal astigmatism would not be indicative of keratoconus. However, we could look at the scale range, the range of curvature with a normalized scale selected. Shows you the flattest the topographer can read on this particular eye and the steepest the topographer could read on this particular eye. And that range of curvature could be indication of normal versus abnormal. This patient has a flattest curvature of approximately 36 diopters and a steepest curvature of approximately 50 diopters, or a range of curvature of 14 diopters. Normal corneas fall under 10 diopters of scale range, so this patient would be deemed abnormal. Eccentricity value is a measure of possible disease. The higher the eccentricity value, the more abnormal the eye. 0.8 would be the threshold for normal versus abnormal, and in ectatic eyes, with the steepest point in the cornea being close to the visual axis, from the steepest point to the flattest, if that's a very broad range of change from center to periphery, that can be indicated in the eccentricity value. So the greater the E value, possibly the better indication of disease. Again, normal would be under 0.8 eccentricity. Another method of determining if this is a diseased or asymmetrical eye is to click on the attributes and look at the IS, the SAI, and the SRI value. The IS value looks at the inferior cornea versus the superior cornea and says what is the average inferior corneal power compared to the average superior corneal power. If the inferior cornea is greater than 1.5 diopters steeper than the superior cornea, that could be indication of keratoconus or pellucid, marginal degeneration. In this case, the patient has 2.67 diopters steeper inferior corneal shape than superior corneal shape, and that would be deemed abnormal. Surface asymmetry index looks at the oblique axes and determines if the curvature across this hemichord is similar in shape to the surface across this hemichord. Are the two very similar to each other or symmetrical across that axis, or asymmetrical comparing one side to the other? And the same thing goes for the opposing meridian. Is this axis similar to this axis? And the higher the surface regularity index is, the more abnormal the eye. The threshold for normal versus abnormal is 0.8. So the higher the IS, the SRI, and the SAI values are, the more asymmetrical the eye shape. And in review, If you have a scale range greater than 10 diopters, that would be considered abnormal. If you have eccentricity value above 0.8, that would be considered abnormal. IS value greater than 1.5, surface asymmetry greater than 1, and surface regularity greater than 0.8 would be indicative of an abnormal or possible diseased eye. This concludes our section on disease detection analysis with your Medmont E300 corneal topographer.